In this video, I'll solve a two-dimensional force problem concerning this here block sitting on a table. This is the problem. A block of mass m equals 20 kilograms is sliding on a table such that the coefficient of kinetic friction between the table and the block is 0.25. When a force of tension Ft equals 80 newtons is applied at an angle of 35 degrees above the horizontal, the block accelerates. Calculate the magnitude of that acceleration. From here, we want to move on to solving this problem. So just laying out some things that we got from this problem, we know the coefficient of kinetic friction is 0.25. We know the mass of the block is 20 kilograms. The angle above the horizontal is 35 degrees. The force of tension is 80 newtons, and we are trying to find the acceleration. So I sketched this little block here just to represent us the picture we were given earlier, and we want to kind of start at the beginning. First thing is we want to define a coordinate system. So I'm going to define upwards as positive y direction, and out to the right is my positive x direction. Next, I want to draw a free body diagram of this box sitting on the table. So we are identifying all the forces acting on this block as arrows starting on this dot. So first up, I'm going to have a normal force going upward. I'm going to have a gravitational force going downward. I'm going to have a force of tension going up at an angle here, and a frictional force going parallel to the surface interface. And you'll notice that my force of gravity is a little bigger than my normal force. That's because tension is going to alleviate this normal force a little bit. And as always, my force of friction is going to be a little smaller than my normal force because we know that the force of friction is less than or equal to mu times the normal force. With correct notation, in AP Physics, it looks just like this. Okay, from here, step 3 is to break our forces into any components. So the only force we need to break into components is our force of tension. So I'm just going to throw out right here on the side that my force of tension in the x direction is going to be equal to the force of tension times the cosine of that angle theta. Now, if I do a little math, that's 80 newtons times the cosine of 35 degrees, which gives me 65.5 newtons. Next up, I'm going to do my force of tension in the y direction, which is Ft sine of theta. Carrying this out, 80 newtons times sine of 35 degrees is going to equal 45.9 newtons. Great, so we've got this all laid out here, and now we want to start analyzing our forces in both the x and y dimension with the goal of eventually finding the acceleration of this block. So I'm going to scoot down a little bit, and I'm just going to lay out the basics. So I'm going to have this side over here be my x direction, and I'm going to say the sum of the forces in the x direction, it's going to accelerate here. We know that. So I'm going to say that this is mass times acceleration in the x direction. Now that's different than in the y direction because we know this block isn't going to just take off and leave the table accelerating into the sky. So we're going to say that in the y direction, this box is actually in equilibrium. So we know the sum of the forces in the y direction will be 0. Okay, let's start substituting in. So we're looking here at the x direction first, and I'm looking at this left side of the equation, and that says the sum of the forces in the x direction. So that's indicating that we need to add up all the forces that are acting in the x direction. And in case you forgot, those are the force of friction and the x component of this force of tension, which we calculated right here. So what I'm going to say is, since I defined positive is to the right, I'm going to say my force of tension in the x direction minus my force of friction is equal to mass times acceleration in the x direction. Now we're trying to solve for this MA, or for this acceleration in the x direction. So I'm going to do just a little bit of rearranging algebraically here. and I say the acceleration in the x direction is going to be the force of tension in the x minus my force of friction, all divided by the mass of this block. Now, just yet, I need to keep on substituting, so right now I'm thinking about this right here and relating it to this up here, which is the equation for the force of friction, and I'm going to do a little substitution here. So A of x is equal to my force of tension in the x direction minus mu times the normal force, all divided by the mass of the block. So, unfortunately, we're like, well, what's this normal force? We don't have that yet. We have everything else. We know this force of tension. We know the mass. Like, dang, we got to do a little more. So let's come over here to the y direction to find out our normal force. Since in the y direction, we're in equilibrium, we can do a little math cheat here. And we can say, well, all the forces are going to cancel out. So we've got up equals down. That's saying that the upward forces are going to be equal in magnitude to the downward forces. So what are my two forces acting in the x direction? They're going to be my normal force. I'm going to add that to the force of tension in the y direction, and those will be equal to my force of gravity. Now, I'll rearrange. Normal force is equal to the force of gravity minus the force of tension in the y direction. Do another round of substitutions. Force of gravity is equal to mass times the gravitational field strength minus my force of tension in the y direction. I'm going to plug in some numbers. So I've got 20 kilograms times 9.8 newtons per kilogram. Coming off the page here. Minus the force of tension in the y direction, which I found before to be 45.9 newtons. And that tells me that the normal force, if I plug and chug, is going to be 150.1 newtons. Sweet. So I just found the normal force that I was looking for right here. So I'm going to come back in. I'm just going to maybe show that I've done this with a little arrow here. So I'm going to plug right in here. And I'm going to start substituting some values in back in the x direction. So I know that my acceleration in the x direction is a force of tension in the x, which I solved earlier to be 65.5 newtons, minus the coefficient of friction, 0.25, times this normal force, which I found right here, 150.1 newtons, all divided by the mass of the block, which is 20 kilograms. Now I'm in the home stretch. I just got to plug this into my calculator, and I should get an answer of 1.4 meters per second squared. Now this question asks for magnitude, so we don't need to indicate really anything beyond this, but we could also mention that this was out to the right horizontally. So just to review, let's zoom out a little bit here. Reviewing the steps that we've done. We defined a coordinate system. We drew a free body diagram. We split all the forces that we needed to into x and y components. And then we analyzed the forces in the x and y dimensions, did some algebra ninja maneuvering, and wound up with our answer of the acceleration in the x direction. Thanks for watching.